These are the 6 trig functions, and we're going to find their derivatives. Derivative of sine is going to be cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cotangent would be negative cosecant squared. Derivative of secant is secant times tangent. Derivative of cosecant is negative cosecant times cotangent. These are the derivatives of your 6 trig functions. You might notice some similarities. First off, derivative of all the cofunctions have a negative. So the derivative of all cofunctions are negative. You may notice that secant squared becomes cosecant squared. Secant tangent becomes cosecant cotangent. It's not too hard to remember, but it takes a little practice before you can actually learn them or commit them to memory. Now, we also learned about the product and quotient rule. The product rule allows you to take the derivative of a product. I usually use u times v. And it's going to be u v prime plus v u prime. That is called the product rule. Again, multiplication and addition are commutative. So you could possibly mess this order up and still get this correct. Unlike the quotient rule, the quotient rule allows you to find the derivative of a quotient, like u over v, and it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. You might know, and this is a quotient rule. You might notice it has multiplication, but it has division and subtraction, which are not commutative. So if you mess the order up on the quotient rule, you're not going to get the correct answer. I'm going to do a small example of each before we get into the assignment. Let's say I gave you y. Suppose I gave you y equal 3x squared times the sine of x. First off, identify it as a product. I see 2 things multiplied. I'm going to label one u, the other v. The derivative of a product is u v prime plus v u prime. So I bring down the first one, 3x squared, times the derivative of v. What's the derivative of sine? Cosine. Plus v, which is sine, times the derivative of u. What's the derivative of 3x squared? 6x. So you end up with 3x squared cosine x plus 6x sine x. Yes, you could factor an x out, but that's not what we're doing right now. I'm just emphasizing the rule. This is an example of the product rule. This is a quotient, so you're going to write it as you're going to have to use a quotient rule. The derivative of u over v is v, the bottom, times the derivative of the top, minus the top times the derivative of the bottom, all divided by the bottom squared. So, let's fill these in. What's v? Well, it's the bottom, 2 minus 5x. Times u prime, that would be the derivative of the top, 6x, minus u, which is the top, 3x squared minus 1, times v prime, the derivative of the bottom, which is negative 5, all divided by the bottom squared. Now we just need to clean it up. This would be 12x minus, what would that be, 30x squared. I don't know. Are you okay if I take this let me use a different color. If I take this negative and make it a plus? I hope you're okay with that. What would 5 times this be and 5 times 1? 5 times 3x squared would be 15x squared, and 5 times 1 would be 5. And so if I keep cleaning the numerator up, what do I get? Okay, how many x squareds? Would that be a negative 15x squared? Is it only 112x, I think? And minus 5? All divided by 2 minus 5x quantity squared. Now let me just double check my arithmetic, but I believe this is correct. The assignment in 2-3 is going to be 1 to 55 odds, 95, 97, 121, and 122. I'm going to go through some of the product rules. This is a product, u times v. Its derivative will be u v prime plus v u prime. I always remember it this way. You bring the first one down times the derivative of the second, which is negative 5, plus the second one times the derivative of the first. Basically the other way around. So this is negative 10x plus 15. This would be 2 minus 10x. So I see it as negative 20x plus 17 for my derivative. Okay, on number 3, again we have u times v. So it's going to be u v prime plus v u prime. It's a little harder because you have to take the derivative of the square root of t. Are you aware that that's t to the 1/2? And if you did power base 1 less power, you would end up with 1 over 2 radical t. So basically that's what's going to be the u prime. Just mentioning. Anyway, we're going to do this. What is u? The first one, square root of t, times the derivative of v, which is negative 2t, plus v, which is 1 minus t squared, times the derivative of u, which we just found at the bottom to be this. So now I'm going to rewrite this. Negative 2t radical t plus 1 minus t squared over 2 radical t. You could multiply by 2 radical t. You could factor out. There's a few things we could do to this, but I believe at this point we're just focusing on the rule. We'll do the major cleaning up by factoring later. Any questions on 1 or 3? Okay, 5 is another derivative, and it's another product. So it's u times v becomes u v prime plus v u prime. So you bring the first one down, times the derivative of cosine, which is negative sine, plus bring the cosine down, and what's the derivative of e to the x? The derivative of e to the x is e to the x. So I usually write the positive one first, e to the x cosine x minus e to the x sine x. You could factor out an e to the x if you wished. Again, we're going to be doing that eventually. I'm going to say what I always say is match the answers into the back of the book. That's part of the reason I'm giving you the odds is you have the answers. I want you to check your answers. And sometimes they express them in slightly different forms. So that forces you to manipulate it a little bit. So always match the answers with the textbook, please. Okay, now we have a quotient. This is a little different. You have to use the quotient rule. And the quotient rule is going to be v u prime minus u v prime, all divided by v squared. So let's fill this in. The minus is here. What is v? The bottom. X minus 5 times the derivative of the top, which is just a 1, isn't it? Minus the top, which is u, x, times the derivative of the bottom, which is 1, all divided by the bottom squared. So you get x minus 5 minus x, which really simplifies to just a negative 5 in the numerator. And this is what your derivative is going to equal. This is a quotient rule. They will get a little harder again when you start mixing radicals into them, like number 9, I think, does.
Can you go back for this?
Yes. Okay, number 9 is, like I say, is a little more difficult. It has a square root in it. So if you don't mind, I'm going to find the derivative of the square root of x right now down on the bottom. Its derivative would be power base 1 less power. So the derivative is going to be this. That's simply the derivative of the top. Anyway, we have a quotient, so I have to use a quotient rule. U over v. It will become v u prime minus u v prime, all divided by v squared. And all we have to do is fill everything in. V is the bottom, x to the third plus 1, times u prime, which is a derivative of the top, which we just found down here. What was that? 1 over 2 radical x. Minus u, which is radical x, times the derivative of the bottom, which is 3x squared, all divided by the bottom squared. So all I'm going to do is rewrite it. X to the third plus 1 is divided by 2 radical x. This would be 3x squared radical x, and it would all be divided by x to the third plus 1 quantity squared. Now you have a fraction and a fraction. I'll never accept that as an answer, and we're going to deal with that momentarily. Okay, at this point we need to get rid of the division. I need to get rid of the division by 2 radical x. The opposite of division is multiplication. So if I multiplied by a fancy form of 1, I'm not changing the value. When I multiply here, will the 2 radical x's cancel, leaving me x to the third plus 1? Always use parentheses when you subtract. Now, when I multiply over here, you have 2x squared. Actually, you don't. You have 2 times 3, which is what? 6. You have an x squared. But what happens when you multiply radical x by radical x? You get another x, don't you? So that's times x. And on bottom you would have this if you multiplied your denominators. So anyway, you have 1 minus 5x to the third, because 1x to the third minus 6x to the third, all divided by this. And now this is going to be h prime of x, or the derivative. As I told you, they get a little more complicated when you mix radicals into the quotient rule. I hope these help as a beginning. Good luck.